Okay, 2011 on speed and acceleration. A stone was dropped from the top of a cliff, and the distance that it fell was measured at intervals of time as given in the table below. We've got distance here in meters and time here in seconds. So it is going to fall all the way to the bottom of the cliff, which is 100 meters down, and it's taking a total time of 4.5 seconds to get there. Part 1. Draw a graph of the distance against time draw a graph of distance against time in the grid below. A smooth curve through the plotted lines is required. Okay, on the x-axis here, we've got time. On the y-axis, we've got distance, and they have given us our scale. First point, our time is at 0 seconds, distance 0 meters. Okay, so there is 0 seconds, and there is 0 meters. Now, a distance of 5 meters and a time of 1 second. Okay, we need to check out our scale to answer this now. We need to figure out where's 5 meters on our y-axis. Well, here's 20 meters and here's 0 meters. Okay, so halfway between 20 and 0, that point right there will be 10. So halfway between 10 and 0 will be 5. Okay, so that's where we're talking there. And at a time of 1 second. Okay, so right there's our 5. Go across, meet it at 1 second. And I need to draw my point. Let's try again. There we go. Now, distance of 20 meters, time of 2 seconds. Okay, that's an easier one. There's 20 meters, bring it across to where it would meet 2 seconds. Okay, it meets 2 seconds there. Then, distance of 45 meters at a time of 3 seconds. So there's 40. Okay, there's 60. Halfway between 40 and 60 will be 50 meters. And halfway between 50 and 40 is going to be 45 right there. So that's what we're talking. And we are going to 3 seconds, which is here. Okay, meets up with 3 seconds right there. 80 meters and 4 seconds. There's 80 meters. Okay, and that has to meet up with 4 seconds. Right there. Okay. And then final one, 100 meters after 4.5 seconds. So 100 meters is here, and we want to find out where's 4.5 seconds. Well, there's 4, there's 5 seconds, 4.5 seconds, right in the middle. Okay, so that is right there. Now we want to draw a line between these points. Okay, what color will we go for? Green is a good color, and we'll reduce the thickness a little bit. Okay, hopefully it'll stand out. So we want to make a smooth curve, which is not very easy when you're on a laptop. Much easier when you've got your pencil. There we go. Best I can do. So we've plotted a smooth curve through the plotted lines. Okay, and that means not just straight lines between each point. Okay, smooth and curving gradually up the way. Okay, meeting all of the points. Okay, part 2. Use the graph to find how far the stone has fallen in 3.5 seconds. Right, so 3.5 seconds. There's 3, there's 4, 3.5 is right in the middle. Okay, and that's going to intersect nicely. Okay, let's get a different color. Cyan. Okay, so we want to go up from 3.5, meets the curve there, and then across. Okay, and you could call that, for all intents and purposes, 60 or maybe a little smidge above it. Okay, So maybe, so that'd be 70, that'd be 65, so about 62, we will say there. Okay. So 62 meters. Calculate the average speed of the falling stone between the second and the calculate the average speed of the falling stone between the second and the fourth second. That's a bit of a tongue twister, isn't it? Give the unit of your answer. Okay, so we are looking to calculate the speed. Now, first of all, when you get any question that's looking to calculate speed, you're going to think of your speed equation. Speed is equal to the distance divided by time. Okay, so to answer this, we need a distance and we need a time. Let's see if we can work out what they are. Between the second and fourth second. Tongue twister is right. Okay, so there's the second and the fourth second. Okay, let's go up here. Okay, so the second and fourth second. Okay, now the difference in time between 2 seconds and 4 seconds is going to be 2 seconds. Sorry, the time taken is going to be equal to, so it's going from 2 seconds all the way to 4 seconds. Now to get from 2 seconds to 4 seconds, you need to go plus 2 seconds. So that's our time taken. Okay, that there. Now what is our, sorry, I should have made the big for that. Hope you can see it there now. Okay, now we need our distance between the second and fourth second. So it's going from 20 meters to 80 meters. Okay, so our distance is going from 20 meters all the way to, what was it? Was it 80 meters? It was 80 meters. Okay, now to go from 20 to 80 meters, what is it? How far did it travel? It's going to have to go 2 plus 60 meters. Okay, so that is our distance. Now we can fill these into our equation. The distance is 60 meters. Time taken is 2 seconds. And that is going to be 60 divided by 2, which makes 30. Let's not forget about our units. Okay, here they are. Meters divided by seconds, and the way we say that is meters per second. Okay, next part. We'll put in our answer here for talk's sake. What was it? 30 meters per second. Now, in this experiment, is the distance fallen directly proportional to time? And we have to justify our answer. Now, first of all, we need to know what does directly proportional mean. Let's get out my pen. We shall go with pink. Okay. Now, if something is directly proportional, it will have a straight line graph. Okay. I will do my best at drawing a straight line. Okay. Now, we can see here that we have got a curved line. So this pink line is directly proportional because it's a straight line. Green line is not directly proportional because it is a curved line. So we want to put our answer in here. So no, it is not directly proportional because it is a curved line, not a straight line graph. Okay, I hope you found this useful. And best of luck with the rest of your questions.